This is it's a little LED light kit. It's like Christmas lights, but they're decorative lights. We've got a few of them around the house. Put them in vases and jars, and got a couple in lanterns next to the bed. And I actually use these as bedside lights because you get quite a lot of light from them. So what I'm going to do here is these are quite handy, but they use batteries, and batteries are quite wasteful. So I've already converted most of these. I'll just move this out of the way. Like I said, we've got a few around the house. I'm going to convert this so that I can power it from a USB power bank, and that way when it's done, when it's empty, rather than throwing away the batteries, I can just charge the power bank. A tip I mentioned on a comment on one of Clive's videos, Big Clive's videos this week. If you're taking something apart and you've got screws, quite often I'll just have these. I'll have little, an aerosol lid. And I'll use that to keep the screws together. But if you've got a device that has multiple screws, you can use a pill caddy or an ice cube tray, and that way, as the screws come out, you put them in left to right, and when you're putting the thing back together, take the screws out right to left, and that way they're likely to go back in the same order. You're not likely to lose any or put the wrong screw in and go through the case. In this case there are only 4 screws, so I'm not too bothered about mixing them up. They're different type, different length. I'm not going to be using these outdoors, so I'm not really worried about the glue. This here, what they've done is they've put hot melt glue. Don't know if you can see that, where the cable goes through. I'm just going to break it away, just pull the cable through. I'm not going to use these outside, so I'm just going to take that glue off. And then we've got the 2 outputs, output 1 and 2, and VDD and ground. There's the power in and ground. The main processor on here is a little 8-pin chip, and it has no markings on it. This other one over here, this one looks like, yeah, this is connected to the outputs, so this is connected to these 2 cables which go to the LEDs. So this is likely to be a Darlington chip, which is, it's an IC with multiple transistors inside it. And the way this works is output 1, when it goes live, so it gives a positive voltage, output 2 has to be connected to ground, and vice versa. And that's how, when output 1 goes live, as the power comes on and you give it a duty cycle, it'll go bright, and you do the same with the second one, and it just flicks back and forward rapidly. And to do that, you can either use discrete transistors to connect them. So you would have, on output 1, you would have a PNP and an NPN transistor. One of them would be given at the 5 volts out, and the other one would be given at the ground when it's needed, and the same on output 2. But so when the PNP is engaged on output 1, the NPN will be engaged on output 2, and vice versa. And that's how it gives voltage out on this one and comes back to ground on this one, and then it flicks back and forward. So this chip here will be a Darlington transistor array. So inside here you've got one chip, you'll have effectively four resistors, four transistors, and it just saves you using all the discrete components. And it's quite a nice way to package it as well. It simplifies the circuit board. So what I'm going to do here is I'm going to take the battery terminals off. I can leave them in, but I'm going to disconnect them, and the reason I'm going to do that is if I were to connect the USB power bank directly onto here and leave these in, if someone were to put batteries in here and connect the power bank at the same time, it would cause an overvoltage fault. There's also the potential for short circuit if I don't disconnect them. So all I'm going to do is take these off. I'm just going to desolder that, so that I'm putting some nice fresh solder on rather than using the existing stuff. Yeah, I know I'm touching the solder wick when it's hot, but to be honest, I'm used to it. You do kind of get used to it. You become oblivious to it until you do it, and it's red hot, and then you remember that. Okay. So what I'm going to do, I'll pause the video because I'm going to take these terminals out of here, just because they're in the way. Also because I'm going to drill a hole through here so that I can have the, I'll drill a hole in the top actually, have all the cables coming in the same way. But I'll take these battery terminals out. I'm going to use this USB lead here. Now this is a USB lead that came with a power bank, a Sonix power bank that I got from Amazon. Quite a cheap lead because it's only got 2 cores. Obviously they're positive and negative, but they're not marked in any way. I think one might be slightly grey and one's white. It's really hard to tell. I'm pretty sure that one's grey and this one's white. Yeah, this one here is grey. So I'll meter that and I'll check that before I solder them onto the board. But I'll pause while I do all this boring stuff. Okay, so I've taken the terminals out and I've drilled a hole in here, so this cable will come in through the top and I'll solder it straight onto the board. I need to find the polarity of this cable first though. Just quickly tin these. So meter here, and I'll just bring in the power bank. Careful not to short this. So okay, so the grey cable, slightly grey cable, is the positive and the white's the negative. So whenever I bought some of these, I thought I could get some rechargeable batteries, but rechargeable AA's aren't, or rather rechargeable C cells in this case, quite expensive, and they're not that great because the NiCads and nickel metal hydrides, the capacity is quite a bit shorter, quite a bit smaller than most power banks. And then I realised that the chip, the controller, the microcontroller inside these doesn't have a rating, sorry, it doesn't have a number, so I couldn't look up the data sheet. And these are quite good because they come with remote control. They're quite handy, so they're nice for having about the house, let's say in bowls and things. But if you're having to change the batteries, especially if you've got them inside a decorative container, it means that it's nowhere near as handy. So I thought I need to see if I can convert these. So I bought some, and I bought some extra ones, basically just to try, because there was no way I was going to find out what the chip was, so I just tried it, because I mean, what's the worst that can happen? And they're about £7 each, so I thought if I burn it, I burn it. But I've now converted quite a few of them, and they convert quite nicely. They just work. So I'm assuming that the microcontroller has a tolerance, so it'll have a voltage range. Some of them work from 2 AA's, and they work from rechargeable batteries, so they obviously go all the way down to 3 volts or 3.3, sorry, they obviously go down to 2.4 volts or less, but equally they work just as happily on 5 volts. So rather than put some hot melt glue on this, I'm just going to put a little cable tie on each of the cables as a strain relief, just in case they get pulled. Yeah, I've done this to quite a number of them now, and they're all quite happily working away around the house. Quite a nice little unit. I think this one has, it's either 120 or 160 LEDs. I'm pretty sure it's 160. And this one was the dearer of the two units. I was buying them, I think they've got maybe about 80 LEDs. I bought a few of those, and they were about, I think they were about £5.99 for a twin pack on Amazon. That was with Amazon Prime. Obviously, if you buy them on eBay, you might be able to get them cheaper, but you might have to wait a few weeks for them to come from China. But these were pretty good value, and they are water rated or weatherproof. They have weatherproofed them with hot melt glue, so where the cables go in and where the copper joins to the cable, it's hot melt glued, and you can probably see here that it's been melted, so the heat shrink that's gone over there melted a bit. So I probably wouldn't use them outside. In fact, this hasn't been used outside, and there's a very, very slight hint of green there, so that's suggesting that there's moisture getting in. I wouldn't use them outside anyway, but they do very nicely inside. They're ideal for what I want them for. So there we are. You can cycle through the programs, or choose your program, choose your brightness. And like I said, I use one of these inside a a lantern type. It's obviously meant for candles, but once this is uncoiled, you just sort of shove them in randomly, and it gives quite a nice effect. It's just a nice sort of warm background light. We've got some in bowls around the house, but I wouldn't suggest you read from this. But you know, if you're getting ready for bed, or if you're just sitting about relaxing, maybe watching TV, it's ideal for background light. And on the power bank, because these are lithium power banks, they pretty much go to full. They run at full brightness right until the power bank's ready to go. So I've got one, I think, left on batteries, and as the batteries dim, the LEDs dim. Although it's using pulse width modulation, as the voltage drops, the duty cycle remains the same, but the voltage is lower, so it's still quite lower. Whereas with these, when they get to the cut-off voltage, they cut off, and there's not a great difference between its full charge and its cut-off voltage. So you get a more consistent light level from them. So that's it. Quick and easy to convert. Makes it much more usable. Makes it a little bit more friendly for certainly environmentally friendly, because you're not throwing away batteries. But for convenience, it makes it much easier as well. Thanks, and I'll see you next time.